Hi everyone, Professor Bob Young back at you here, and in this last instructional video we are going to solve linear inequalities and systems of inequalities. Now, a linear inequality in two variables is an inequality in the form ax plus by is less than or equal to c, where a, b, and c are real numbers with a and b not both equal to 0. Now, that less than or equal to symbol, of course, could be with inequalities, greater than or equal, less than, or greater than. The graph of a linear inequality is a half plane, perhaps with its boundary. So, for example, to graph the linear inequality 3x minus 2y is less than or equal to 6, first graph the boundary, which in this case is the line. Now, since the points of the line satisfy the equation, this line is part of the solution set. All right, now notice here the line goes through 0, -3. All right, so if I put 0 in for x, I would get 3 times 0 minus 2. And if I put -3 in for y up top here, I would end up with this statement, 6 is less than or equal to 6, which is a true statement. So notice down here on the bottom, I've got for any symbols with an equal to in it, less than or equal or greater than or equal, you'll get solid line figures. Now this means that all points along this line, if I plugged them in here, would satisfy that inequality because I would get 6 is less than or equal to 6. Now if it doesn't have the equal, if it just has greater than or less than in your inequalities, you're going to have what's called dotted line figures. Now what that means is that no points on the graph will satisfy the inequality. Okay, so we'll look at that more as we progress here. Now, to decide which half plane, the one of the line 3x minus 2y equals 6 or the one below the line is part of the solution set, let's go ahead and solve the inequality for y, because we like that slope-intercept form better than that standard form, if you remember equations for lines here. So what we're going to do is just go ahead and take the standard form like we did way back when and subtract 3x from both sides and then divide everything by -2, watching our signs. And also notice, whenever you divide this inequality by a negative number, flip it good. So good exam review here. So y will be greater than or equal to 3/2 x minus 3. All right, now for a particular value of x, the inequality will be satisfied by all values of y that are greater than or equal to 3/2 x minus 3. Thus, the solution set contains the half plane above the line. So that is the solution set there. Now, notice it says here comes a caution flag. A linear inequality must be in slope-intercept form. In other words, solve for y to determine the presence of a less than symbol or a greater than symbol, whether to shade lower or the upper half plane. Now, in the previous slide, the upper half plane is shaded, even though the inequality is 3x minus 2y is less than or equal to 6 with the less than symbol in standard form. Only when we write the equation, the inequality, I almost said equation there, bite my tongue, as y is greater than or equal to 3/2 x minus 3, slope-intercept form, does the greater than symbol indicate to shade the upper half plane. And we're going to find some other ways to make sure we shade in the right spot as well. All right, let's try another example here. Graph x plus 4y is greater than 4. So we're going to act like that's the line x plus 4y equals 4. And then we're going to decide which half plane represents the solution set here for y. So again, let's go ahead and get this from standard form to slope-intercept form. So we're going to go ahead and subtract x from both sides, leaving us with 4y is greater than -x plus 4. Divide by 4. Do we flip? Do we flip? No, not in this case, because we're dividing by a positive. The negative will not impact it, so do not flip the inequality, and you'll get y is greater than negative 1/4 x plus 1. Only flip the inequality whenever you multiply or divide by a negative number. Now, since y is greater than that negative 1/4 x plus 1, the graph of the solution set is the half plane above the boundary. So this will tell you this symbol right here, when it comes to a line, once you're in slope-intercept form, to shade the greater above or the less below when you get it. Another way to check this is you could substitute a point in here. Now, if you would have graphed it, let's say you like standard form and you would have graphed that same line. Remember, you could get the two intercepts. You could let x be 0, which would give you 1 for y there. If you remember how to graph in that form, here's one point. You could have let y be 0 and solve for x, and that would have given you this point. Now, since this has the greater than, it doesn't have the equal, we've got our dotted line graph there. All right. Now, another way to figure out where to shade is to take a test point. Now, a lazy test point is 0, 0. So in other words, if I put 0 in for x and 0 in for y, notice I get a false statement here. 0 is greater than 4. I don't think so. So since 0, 0 failed the test, every point down here will also fail the test. Like you could take negative 1, negative 2 and try it. Survey said, you could take negative 10 way out there, every point below that line. Positive 2, negative 3, They stop it, Young. Now, every point in the shaded region will satisfy the inequality. So what I like to tell students is don't shade what don't work, shade what works. Did you want to check a point over here to make sure? Let's take the point 0, 3, and I'll put a big point here. Let's check 0, 3 and just show you here. So in this inequality, if I put 0 in for x and 3 in for y, I will get a true statement. 12 is greater than 4, true. So every point in the shaded region satisfies, every point on the other side does not. Okay, let's just keep going here. So graphing inequality, so for a function f, the graph of y is less than f of x consists of all the points that are below the graph of that function, which most lines are functions. The graph of y is greater than f of x consists of all the points that are above the graph there, above the line. If the inequality is not or cannot be solved for y, choose a test point not on the boundary like we just did in that last graphic there. If the test point satisfies the inequality, the graph includes all points on the same side of the boundary as the test point. Otherwise, does not work. Now, let's solve some systems of inequalities. So we're going to next graph this system. X is greater than 6 minus 2y, along with x squared is less than 2y. Now, that's going to be the intersection of the solution sets of its members. So we find this intersection by graphing the solution sets of all inequalities on the same coordinate axes and identifying by shading the region common to all graphs. So what I want to do here is first, let's go ahead and graph the line to the left here. All right. Now, again, if we wanted to graph this line, we could solve it for y here. So we could add 2y to both sides of the equation, and we could move the x over by subtracting x from both sides of the equation. So this would give us 2y is greater than negative x plus 6, and then divide everything by 2, which would not change the inequality. So y would be greater than negative 1/2 x plus 3. Now we would start on 3 here if we were just graphing the line by itself, and then we would go down 1, right 2, with the other point in slope-intercept form. So good graphing exam review here. Dotted line because it does not include the equal here on the inequality. Okay. If I check the point 0, 0, let's see if 0, 0 works here. So we're going to check 0, 0. If y is 0 and if x is 0, what do we end up with? 0 is greater than negative 1/2 times 0 is 0 plus 3. Is 0 greater than 3? So on the line, 0, 0 has failed us. Tells me to shade this way. Notice our friend the parabola here. If we were to go ahead and solve for y here, we could divide both sides by 2. So we would get on the parabola 1/2 x squared, or x squared over 2, is less than y, which we could also write y is greater than 1/2 x squared. So notice here we have a parabola with the origin at 0, 0. And if we took a few more points here in graphing this parabola, which is always a good idea, we could put in 1 for x, and we would get 1/2, negative 1, 1/2, and you can hear my phone ringing there, I'm sorry. And here would be some more points. Oh, these solicitors, they just bother you all the time here. So anyway, go ahead now, and if you connect the dots, you could get a few more points in here as well. We could go ahead and put in 2 for x, and then on the parabola, 2 squared is 4, half of 4 would be 2, so 2, 2 would be here. And remember the old buy one, get one freeze when you're graphing parabola, because you have that axis of symmetry, which would be the y-axis there. Now, Young, where do you shade a parabola? Well, you could take a point inside or outside. Now, if you're going to shade a parabola, you're either going to shade it in or out. So I'm going to take the point 0, 4 as a test point. All right? So if I put 0 in for x, 1/2 times 0 squared, and 4 in for y, notice 0, 4 is true, and that's where you shade. That point worked. Now, if you're combining both of these graphs together, which we're going to do, all right, you only shade what they have in common, the intersection of both points. So notice on the line, we shaded everything on the line this direction. We shaded everything on the parabola inside. So the only point of intersection would be this solution set right in here. So when you graph systems of inequalities, shade what they have in common. All right, let's try some more examples here as we finish it out, and hopefully I won't get any more phone calls. The absolute value of x is less than or equal to 3. Now, another good exam review question, if you were solving this absolute value inequality for x, remember the solution set would be all x values between 3 and negative 3. So here would be graph number 1. Y is less than or equal to 0. Now remember, that is a horizontal line going through y at 0. And if its number's less than 0, it would be on y going this direction. There would be graph number 2. And graph number 3 would be a V. And if you remember your shifting from previous lessons, shifted 1 unit up. All right, now notice all of these are solid figures because they all have the equal to and the inequalities. All right, now notice if we took a test point on the V, let's take and check 0, 0. I bet you 0, 0 is not going to work. Does anyone want to bet? $100, lunch, quarter? All right, let's plug it in and see here. If I plug 0 in for x and y in this absolute value inequality, I end up with 0 is greater than or equal to 1. False down here. So we're shading inside, and if you took any point inside, it would make perfect sense. Now, what happens when you put all 3 of these together? All right, I mean, if you're looking at these, and I'm going to kind of flip through here, and these next few graphics are just telling you what I told you anyway. Okay. When we get down to it here, since the solution sets of y is less than or equal to 0, y is greater than or equal to the absolute value of x plus 1 have no points in common, the solution set is no solution. Now, if you can see a place where all three of these have something in common, let me know. All right? Because what I can do is go ahead on this v here, and I can go ahead and put in, watch this, the -3. So we'll make a line here. At least I'll try to. I may not hit it perfect, but give me a chance here. Okay, there's a line. So I'm going to take this one graph and bring it over. And then I'm going to try to take another line here. Okay. So now I've got this brought over here. So I would have everything in here shaded. So if it were just these two things, then it would be the shaded region. But if they ask you, let's throw in this graph in here, all the points below here, what in the world do they have in common? Nothing. So in this case, there is no solution, the empty set. Does that bother y'all? I thought it might. So while I gave 3 graphs in the solutions of the last example, in practice we usually only give a final graph showing the set of the system here, the solution set of the system. So in the last 2 examples, let's go ahead and do one like I would like to do if I were in class, and we'll review some more for the final, and then we'll be done. All right, hopefully with the x square and the y square, here's good exam review, everyone would recognize this equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared. So the center of this circle, if you remember here, if we're going to graph this circle, the center would be 0, would be the h number, the k number, -3. And if you miss that center, it's all over. So I'm going to go ahead and put the center of the circle at 0, -3. The radius number, r squared, would be 4. Taking the square root of both sides, r would be 2. So we would have a circle from that center point, 2 to the right. Remember how to graph a circle. And remember, my writing tablet sometimes gets a little slippery on me, so be careful. 2 up, 2 left, and 2 down. Solid or dotted circle. Well, this inequality here does not have the equal in it, so no points on that circle will work. So I'm going to go and try to make as pretty a dotted circle as I can. Now, don't pick on my circle, or I'll look at yours when you turn yours in. All right, where do you graph here? If I check, you know what point I'm going to check because I'm lazy on the circle? 0, 0. Does it work or not? So let's see. I'll have 0 squared plus 0 plus 3 squared is less than 4. Well, 0 squared 0 plus 0 plus 3 squared would be 9 is less than 4. That's false. So what I'm going to do is make a note to myself, if this were the only thing I was graphing, I would shade everything inside the circle since 0, 0 failed the test. What do y'all think? Now we're going to graph the line y is greater than or equal to -2/3 x plus 1. So I'm going to start at 1 here, and I'm going to go down to right 3. And I'm going to put what kind of line, solid or dotted? Well, in this case, it would be solid because of the equal to. So let me go ahead and put that there. Now, since this is in slope-intercept form and it's greater than or equal to here, you would shade which way? It would be everything above the line with the greater than symbol. And if you plug 0, 0 in there, it will also be false. So what do you shade? Again, nothing in common. The answer? No solution. Young, how could you do it to us twice? You can't possibly leave us for the end of the semester, the last video of the course, without any answers. You know I won't do that. Let's do one more and be finished with the course. So hopefully you recognize in this last system we're going to graph, the first inequality would be a parabola. And this is that standard form of a parabola. I just wanted to see if y'all knew that this would shift 7 units down, and which way horizontally? Good exam review here. 1 unit left, I hope you were thinking. So the vertex of my parabola would be -1, -7. So I'm going to go ahead over here and make a set of ordered pairs here. Would the parabola smile or frown, ladies and gentlemen? Oh, the things he asked us late in the course. This parabola would smile because the A number is positive. If you remember, you may have to go back and check or past lessons if not. And let's do 0 for x. If I plug 0 in for x here, I'll come over here on the side, I will get y equals 0 plus 1 quantity squared minus 7 will give me a -6. So 0 minus 6 shows me that's going to smile. And buy one, get one free. If you remember parabolas, you've got that axis of symmetry right through that vertex point. Let's try one more point. Let's put 1 in for x. That will give us y equals 1 plus 1, which is 2 squared minus 7. Well, 2 squared is 4 minus 7. So when x is 1 in the parabola, y is -3. And buy one, get one free. Solid or dotted parabola, the inequality tells me dotted parabola. Here we go. Now don't worry, I'm not going to empty set you on this one. There is going to be something in common to both figures. Young, I knew you wouldn't let us down the last video, the last example. So if I check 0, 0 here, and I'm going to do this in green, it's time to switch colors. We've got to show you the full magnitude of the telestrator here on the last one here. Check 0, 0 in this parabola. What do we get? 0 is greater than 0 plus 1 quantity squared minus 7. So 1 squared is 1 minus 7, so we get 0 is greater than -6. That is true, ladies and gentlemen. That tells me, since 0, 0 works, to shade inside the parabola. And now, the line. Where would this line go? I'll do it in a different color here. Let's pick red, or no, orange for the line. This line starts at 5, slope-intercept form, and goes where? Up 2 over 3. Rise 1, 2, run 1, 2, 3. Okay, rise over run there, and I am going to get my line tool and try to get this thing here. A nice orange line here to finish up the term. And don't forget to put arrows on your figures. I hope I've taught you that, because these things just keep going endlessly in both directions, the parabola and the line. And since that is less than on the line, guess which way we would shade? Everything this direction, ladies and gentlemen. All right, so the solution set is what both have in common. Everything inside the parabola and everything below the line would get this shaded region as the solution set of the systems of inequalities. And that is all of those points in that green area will satisfy both. So I hope you all enjoyed the course. It's probably getting ready to be exam time, so it might be time to go through those final exam study guides and so forth and prepare for the last exam and to finish the course. So Bob Young signing off. Take care.